Alright, operational amplifiers continue. Youthful circuits, operational amplifiers. Eugene Melkov, College William Mary, week 10. Resistor, voltage in, frequency, resistor capacitor, voltage out, frequency, voltage out equal to voltage, integral Fourier spaces, and integrator low pass. We need amps equal to voltage in over the resistance. It's just the amp, the resistor 1, capacitor, voltage out, lamps. The only problem with the gain frequency is equal to voltage, the impedance current over the resistor of the 1 over the amp, the frequency of the resistor 1 times the capacity. But the only problem with the remaining of the DC voltage applied with the input output of the rail at the power supply voltage. This could be enough to the lack of feedback with the DC capacitor blocks everything. Show the resistor 2 with the capacitor when resistor 1, voltage in, voltage out, ground. The gain of the frequency of the voltage capacity is parallel to the resistor 2 over the resistor 1 equal to the negative resistor 2 over the resistor 1 times 1 plus 1 times 1 divided by 1 plus amp frequency resistor 2 capacity. The only problem remaining with the DC voltage is the input with the output with the rail each power supply voltage. And I believe the smaller input is the amp. And voltage input with the frequency of the capacitor of the equals 1 capacity of the N to the system of limited amp dt amp time with the result with the capacity with the distance of voltage in with the distance of the time. Voltage out equals negative amps over the resistor of resistor 2. Voltage out resistor 2 with the capacitor the distance voltage in over distance 2. Fourier space differentiator compensated. The thermistor okay, that wasn't very great, but I'll read you the next set of let's look at it in chapter 10. Op-amp circuits of the detector filter power applications. You can improve the performance of the most circuits of the bill with the supports for the include the RC circuit with the rectifier with the op-amp with the negative feedback. 1. Active filter with the RC integrated with low pass filter with the recall the low pass filter with the integrated with the high frequency with the RC with the integrator will be with the laboratory limited with the integrated with the current charging with the capacitor change with the capacitor charge up with the circuit with the integrated only a small voltage but putting in the integrating capacitor some of the op-amp feedback loop for the input side of the capacitor always the same voltage virtual ground. The input current no longer depends on how much charge is doing. The integrator works all the way up until the maximum output of the operational amplifier circuit is shown in figure 10.1. Output will be voltage output is in a system of the voltage input with the distance of the time over the resistance or over the capacity of the resistor and capacitor. Of course, you're limited with the low frequency behavior of the integrator will also with the rail integrate with a small offset voltage with this done by putting in an extra resistor with a slowly bled charge for the capacitor over the time. But B, the RC, the differential high pass filters, putting the capacitor input using the feedback resistor constructively accurate with the differential with the time of the operational amplifier with the shape of the no input if it has been internally compensated for our circuit. The figure 10.2 with the output with the voltage output with the negative resistance to capacity time the distance of the voltage input with the distance time. Show the not through with limited gain at high. Figure 10.2 show the operational differentiator. Show the capacitor and the voltage input going to the resistor for the negative with the voltage output and positive being grounded. And that was a picture of the differentiator. The frequency will degrade the performance of faster additive. The two of the current sources of the inherent negative feedback present with the op-amp circuit the ideal with the making high impedance with the constant current sources of the ideal current sources having high output impedance. Op-amp current source. Current source can be made of an inverting amplifier shown figure 10.3 with the current load resistor must be the sample with the resistor 1 with the current adjusted input of the voltage divided by resistor 1. Alright, op-amp transistor current source. An op-amp combined with a transistor to make with the current source on which the load is outside of the feedback loop with depicted below with the non-negative joint field effect of the transistor can be played with the negative power with negative metal oxides field effect transistor field effective transistor based circuit will slightly better current regulation than metal oxides field effective transistor should be higher for the current application. So the supply, the load, the control, the resistor, the amplifier, the supply, the resistor, the current, the resistor load. So we switch them from positive to negative in each situation. As you can see, with this one's going from resistor, the load's going in control. All right. The amp or the transistor current source for the ground loads of the two previous circuits with the excellent current source for the required for the load may be some with the voltage around above the ground. Frequently, one side of the load will be ground, but in the case of the other similar circuit with the required with the figure 10.4 shows the circuit of the diagram of the constant course of constant current source of the ground with the load base with the positive joint field effective transition. Positive joint field effective transition can be replaced by positive metal oxides field effective transistor high current applications. 3 operational power amplifiers. Amplified quasi-perfect amplifiers. They cannot source the sense of the low amount of current necessary with a higher power application combination operating for the one or more transistors that can produce a high quality amplifier with a high impedance for the input with the amplifier provided with a high fidelity single measurement and gain while the output transistor provide high current with the inclusion of output transistor, the amp for the feedback loop with the help of the linearized amplifier performance, amp with the emitter follower, the amp with the negative positive negative emitter follower. See chapter 6 combined to make with the class A power amplifier to depict in figure 10.5 with the below with the negative positive negative transistor can only source current. The current can only go for the collector to the emitter. The input with the amplifier voltage input must have the positive bias. So the voltage control the voltage going into the positive, the voltage supply, and then we have a collector emitter, resistor 1, resistor 2, resistor 3. B. Op amplifier push-pull buffer. Push-pull amplifier seen in chapter 7 incorporated with the feedback loop of the operational inverter amplifier class B bipolar power amplifier shown. Figure 10.6 with the feedback loop with the automatically remove the crossover the direction of the D with the 0.6 volt with the diode drop so long as the slew rate with the operational amplifier can keep up. So over here we have the push-pull buffer and the amplifier resistor and for the op amplifier rectifiers and putting a diode feedback loop with the op amplifier along with the resistor left of the inverter input flow with the compatible with the rectifier eliminates the problem of the voltage left than 0.6 volts of the diode turn. See figure 10.7. Improve the rectifier circuit with the figure 10.8 with the keep of the output with the op amplifier has been driven the rail with the circuit with the blocking with the wrong signal input with some of the op amplifier limited slew rate with the improvement of the performance eliminated 0.6 volt offset single diode introduced. Figure 10 shows that there was the operational op amplifier rectifier. We've now been introduced a diode. Improved op amplifier rectifier. So for photodiodes. Photodiodes are a type of diodes produced with the reverse bias current with the positive and negative junction illuminated. With the photocurrent with the proportional with the number of the incident with the photon with the quantum efficiency of 0.5 to 0.9 photoelectrons per incident photon. Alright, something photodiode circuit with the simple circuit with the read with the current with the photodiode with the conversion of the voltage of the resistor shown figure 10.9 below with the current circuit with a very simple they have the disadvantage resistor low photodiode with maybe produce the voltage drop with the resistor photodiode with the capacitance proportional to its area which also determine the time of the responsibility of the time of the equals RC. A simple circuit that makes it clear whether you have a high sensitivity, high speed at the same time. So we have a photodiode resistive current to voltage converter. We have diode going and resistor low voltage out and ground. A voltage which a photodiode must produce a larger output current with a photodiode the larger the remainder of the proportional light intensity of the op amplifier remedies of the problem keeping the voltage curve of the photodiode with equal to 0 for light intensity while amplifying the signal of the current voltage converter with the circuit figure 1010. 1010 show the photodiode with the op amp current voltage inverter amplifier. High-speed photo circuits. The positive negative junction from the capacitance of the photodiode can be reduced significantly with the reverse bias voltage of the photodiode with the shown with the circuit diagram on the right of figure 1011 and since the capacitance of the drops to show the time response the time is equal to the resistance still with the time resistant resistor on the capacitor over the photodiode in practice with the fastest diode that has very small detection areas are operated with the reverse bias made with a small load resist the reversing bias helps to improve the time response with the photodiode with the fastest signal with a reduced to the sensitivity of the very weak little signal with a very reverse bias but voltage also drive with a small leakage Across positive negative junction, large leakage current of the direct current has a noise associated with the limited sensitivity of the photodiode at very light levels. One problem is simple reverse bias circuit in figure 12. There was the photo current with the higher light intensity effect with the bias voltage across the positive negative junction. The change as well with the entry of the nonlinear response with the behavior of the photodiode. The op amplifier can be used to keep the photodiode reverse bias voltage constant for illumination initiates, but also converting the photo current to an amplified voltage. In practice, capacity and photodiode with the op amp into oscillation with a small feedback capacitor and the parallel feedback resistor. Design exercises in the lab. That was Chapter 10, Op Amp Circuits for the Detectors, Filters, and Power Applications.